Hey there, Dengar Stu here. Today's video is about installing an alternator in the trawler and is proudly sponsored by marineengine.com. So, I've got a new alternator. The other one was really manky. The engine bay on this boat had filled up with water. The boat itself hadn't sunk, but the engine bay definitely flooded, hence our problems with the engine itself, but definitely the alternator. Really a no-brainer to replace it. They're actually quite cheap. This I got from an auto store for, I think about 200 bucks, something like that. So for the peace of mind of having good, current generation, it was obvious. This is physically identical to the old one, so mounting it should be pretty straightforward. We'll probably do a bit of shimming, but we'll cross that bridge when we come to it. All the wiring's been removed though, so we're going to have to run all new wires for this alternator. The wire I've chosen to take the current to the battery is 8-gauge wire, which apparently is about 3mm square. 8-gauge may be slightly overkill, but I may also upgrade this alternator at some stage depending on our power requirements down the track. So, I'll start by crimping some terminals on one end while we're here, everything's here, then we'll jump down in the engine bay. I was actually planning to buy 10-gauge wire for this 50 amp alternator, but in the end they had 6 or 8, so I've gone the 8. Positive, a little bit of red heat shrink just on this one. I wish my heat gun worked on the generator. Okay. Here's our oil pressure sender, which we're going to rig up to probably today, and the mount for the alternator and how we tension it. Okay. Looks like it'll fit. They just need a bit of persuading. This bolt only just fits through the bracket part. I think the bracket's 3/8 and the alternator's 10mm. Being German. If you look along these two pulleys, you can see they're not at the same angle. I did actually notice that the little tabs here were bent before. I somewhat foolishly straightened them, but it looks like now they were bent for a reason, so let's put them back where they were. We're shooting for the middle groove on this pulley here, and to line it up properly I'm going to have to shim inside the back here. To do that I'm going to use some spring washers. Normally you'd use a flat washer, but the use of spring washers has actually become quite fashionable since I ran out of flat washers this morning. Alright, I'll just tighten this up a little bit, not so tight that we can't pivot it. Get our tensioner bolt in. Well, it's not really a tensioner, it's just a bracket. We tension it by hand. I'm going to get this close to locked off so that it doesn't take too many turns when we do get the tension on, the right tension on. Nothing worse than holding the tension, having to wind it a million times. Alright. Too tight. Alright, that can move still. Alright, obviously we have to keep this up out of the way somehow, but we'll have a think about that in a minute. Now with the tension on these belts, too loose the belt slips, which will burn the belt up, reduce our charging and put our tacho out. So obviously we need it not so tight that it's slipping, but at the same time too tight and you can start wearing out the bearing inside the alternator. So the alignment doesn't look 100%. It looks like the alternator kicks back slightly, so I'm going to put a bar on it and just try and flex it a little bit back into line. Then I might actually run some beads along the base just in case we've weakened them with the flexing. Belt tension now, the alignment's pretty good, I reckon. Now we need to think of a way, probably to here I think's best, to keep this hose from not rubbing on the belt at all. So let's have a look what we can do to fix that. This conduit splits here, so I'm going to pull this one out, see if I can get a T-piece in here, and this is where I'm going to bring all my like sensors and alternator wires into the loom. Come down, it's only got to come down to here so it can join this junction box and head up to the wheelhouse. Alright, let's attach the cable we made. This B terminal here goes to the positive of our battery, and the casing here is going to go to negative. Alright, these are a little 8mm nut. 13. Alright, I'm going to leave a bit of a drip loop, so we'll go down first, then we'll come up, and we're going to come into here. This conduit is a split conduit, so I can separate it. I thought I had a T-piece for here, but I don't. I've only got some 9-degree bends. So I've just ordered some online. They'll take a few days to arrive, at best. So anyway, what we'll do is we'll push on with the wiring and I'll feed it all through the conduit later when that arrives. Next job is to put a whole lot of these female spade connectors onto this multi-core. This is then going to attach to our breakout box from the wheelhouse and run out to all the sensors and the alternator and everything in the engine bay. Okay, I'm going to hit these with a heat gun once we get to shore, but they're all in the correct order, so we're going to put a new loom in the same order and then start running it out to our various devices. Alright, what do we got? Green. White. So, got our grommets, got our cover. Alright, let's push this one through. Alright, once again, just going to leave a little bit of a loop. So any water that runs down, you know, drips, no big deal, take some tension off. To hang the wire and the hose, I'm just going to put some heat shrink around this cable tie. Alright, now I'm just going to run some silicone self-amalgamating tape around it, just to give it a soft outer surface. Okay, so it comes down now through where the T-piece is going to be installed when it arrives. The hose and the wire here are held very loosely, bit of a gap on the outlet to the raw water, which is relatively cool, and it keeps both the hose and the wire away from the exhaust and away from the moving belt of the alternator. Now, one of these wires, first put of call, is the D positive, which is the field coil exciter for this, because it can't self-excite. We need to pass current to this alternator for it to work. I'll show you that in a second. But from there on, we have to go to all sorts of things. Our oil pressure sensor, our coolant temperature sensor. So I'm going to get to here, then from here onwards I'm going to very carefully cut the outer shielding or the outer casing away from this wire so that we can start heading off in different directions. The brown wire in this loom goes to the tacho, so we're going to cut this one out, yay. Crimp a female spade connector on. All up, we're connecting 4 wires to our alternator. A battery negative, a battery positive, so this is where our charge current goes into the battery. Then D positive is going to be positive 24 volts coming from the light on the dash to excite the field coil. I'll talk about that in a second. And then our W wire here is going to our alternator, because that gives us the AC current from here, and the frequency of the AC current tells us how fast the motor's turning. And now I am going to cut the blue wire. And this is going to go to the light on the dash to tell us when we're not getting charge current, but more importantly, to provide the exciter current for the field coil. Alright, this is the positive to our main starter battery. Now, I don't have anything on board that'll let me do it now, but it is my intention to fuse that wire down the track, in case you're wondering. It's also going to need a pretty chunky fuse, like a 100 amp fuse or something, so leave that with me, it won't get forgotten, because I know you guys won't let me. Alright, so negative to battery negative. All the negatives are tied together, so it really doesn't matter that much where you put it. This light here is going to be our alternator light. It's a 24 volt light. I actually had to get the light housing and then buy a 24 volt globe because it came as 12. But the idea is, let's take it out of here for a second. Oh, sorry, hot today. This is kind of the tricky part of it. Not tricky, but it's the bit that's not so obvious. So let's quickly jump to the workshop and I'll show you the circuit diagram of how this all works together. Alright, the way the alternator works is, have our alternator here, and obviously belt driven, blah blah blah, all the mechanical side, but what we have is a B terminal, and this is going to go off to our positive side of the battery, so positive, negative like this. Then the casing's ground, this is going to come over to the negative side. What you often see is that there's a positive lead off the alternator going to the positive lead here on the starter motor. You then have a cable coming from the positive of the battery to the switch, then down to the starter motor, and that's how it ends up going to battery. There's two big problems with this setup. One is that the engine can be running. You can then turn the main battery switch off, the engine keeps running, there's no path for the current to get back to the battery, which will kill your alternator pretty fast. The other problem is this lead here going to the starter motor can't be fused, whereas ideally you would have a fuse in line here. So we've got an unswitched fuse line going straight to the battery, rather than an unfused switch line going to the starter motor. So this is the way we're going to go. Now, there's two other leads. We have a W, which gives us an AC pulsed current that goes off to our tacho. Then we also have a D positive. This then goes to a lamp on the dash, and this lamp ultimately is connected to the positive of the battery. When the engine's not running, this D positive is essentially tied to ground, which means this little light will glow because we've got positive coming here, coming through the globe, going to D positive, which is ground. Once the alternator starts spinning up, D positive becomes plus 12 volts. And because you then got plus 12 volts on this side, plus 12 volts on the other side, there's no, voltage differential, so the light goes out. This current that flows through the globe generates a magnetic field through the field windings, and this is what allows the alternator to generate current. If you don't have plus 12 volts coming into D positive, the alternator will never generate current. It can't self-excite like that. So as well as telling you whether your alternator's outputting current, i.e. the engine's running, the alternator's working, you actually need this for the alternator to work. This isn't just an indicator, it's also a critical part of the alternator actually functioning. So that's the way we're going to wire it. So currently we've got 0.3 amps going into the battery bank above and beyond what we're drawing, so we know that. And we have the globe on. It's a little bit dim, to be honest with you. Not super impressed with that, but we can always change if it's a problem. Now, this means we've got current flowing to the alternator because the alternator is the ground for this light, so we know it's connected. Alright, let's go open the Seacox, fire the engine up and see if the light goes out. That's kind of test number one. because of my fuel supply problem, I can't actually run this engine long enough to do any really good diagnosis on the alternator or testing on the alternator. I do have what I think is a temporary solution to that, where I'm actually going to rig everything up ready to install the new fuel filters, but I'm just going to bypass them. Don't get me wrong, there's still 2 of the 3 in line, so I think we'll be fine. The fuel tanks were cleaned, were wiped out. It's clean diesel. I don't think it's going to be a problem. But that might get us going until these parts arrive. But what I found when I ran the motor is that the Bulmar battery monitor showed I was getting about minus 10 amps. I was talking to Leon about this last night and sort of saying, look, my theory is the VSR is activating and then the batteries are in parallel. The starting batteries are quite flat, which I know. The house batteries are then getting drained to charge the starting batteries. So Leon said, look, a quick test for that is leave everything off, go and parallel them and see what the battery monitor reads. Great idea. Thank you, Leon, as always. So let's go do that and see what the battery monitor says. It's been raining. Oh, look here, I've got my little birds on the bow rail. Hello, little finches, I think they are. Pretty miserable morning, but the sun's come out a little bit now. And as a result, we're back to, 0.4 of an amp or so. Okay, let's turn our emergency parallel on. See what this says. It might take a little while to give a reading because I don't think it's an instantaneous reading with this. It sort of looks at historical information. So far no real change, so it sort of rules that theory out maybe. The VSR is a special relay that when it detects a charge current on one side of the relay, it connects them. So it actually parallels the batteries only when they're charging and then disconnects them when they're not charging. That switch I turned, on the other hand, simply puts them in parallel manually and permanently until you change the switch. Another thing that rules that theory out is that the light is on here on the relay, which shows it's actually in its connected state anyway. And that confirms what we were thinking, which is that the solar goes to the starter battery side anyway. So, let's keep looking. This means though that I need to be able to get the engine running long enough at high enough RPM to start probing around with a multimeter and see what's going on. Alright, I'm going to rig up a new air gun for the boat. I ordered a set of these fittings that are stainless steel, both male and female. The females will particularly be useful for the air hose because we'll be lowering that below water when we do our lift bags, etc. And because they've got moving parts, they don't like corrosion very much at all. Don't need too much. As a classic example of not being able to see the forest for the trees sometimes when you're working on your own, I was here with Pete the other day talking about this fuel line, brazing it, and he said, it does come out, doesn't it? And I went, yeah, it does. So let's remove it, get it on the bench, cut the end off, braze the new fitting on. Compressed air did an amazing job of getting all the diesel out of the fuel line. Alright, got it. Alright, I managed to bend it and crush it while I was pulling it out, but that's okay because we're cutting it just here. I think the little cutter will do easily. These cutters, just tighten it, run it round, tighten it again. Just keep going round, keep tightening. Really common tool at any plumbing store. There's also like a sort of a wedge-shaped tool you can put in here to deburr it and everything, which is more important if you're going to flare it. But we're brazing a fitting on the outside, so I don't think it's going to be a massive issue. Now, this fitting, I believe, is ever so slightly too small. It's actually threaded. If I had a big enough tap, it'd be great to actually tap this, thread it on, then braze it. But I'm going to drill that out instead. Alright, I'm going to clean that thoroughly before we even test fit it so we don't get any of this stuff inside the fuel line. It's a pretty tight fit still, but I think it'll go on with a few taps. So let's clean up the copper, put some flux on, tap it on, braze it. Alright, pretty confident that doesn't have any debris from the sanding in it either. Now, don't have a brush here, but my stirrer will have to do. Just trying to get a bit of heat into it first. That's not too bad. Alright, let's turn our fuel cocks back on again. Can't reach them. Now, down there's our new braze fitting. This needs insulating with a bit of nitrile, clamping down, all sorts of stuff like that. Oh, just, that's good. It's going for a while. Oh no, still going. Oh, that's good. Now, this fuel line ultimately is going to come up to the filter here. I don't see any reason to cut it at this stage, other than the fact that it's got a lot of air in it. So we might suck some fuel through this and then quickly throw it on that barb there directly. To get the revs quite high for the charge light to go off. As soon as I had the light go off, this is when I get this minus 10 amps thing. Got to figure out what's happening there. Alright, got our gasket on the front of the blower silencer. The last thing I kind of consider essential before we do our cruise, if you consider having no primary fuel filter not essential, is just get these gauges wired up properly. It'd be great to see what the oil pressure is, what the coolant temperature is, that kind of stuff. Now, this is my oil pressure gauge, which if I turn it this way up for you, looks like we've got an S and a WL/G. Whereas the instructions I found say G is sender, then there should be a ground. The frustrating thing about being inside a steel boat is it's also a bit of a Faraday cage, so you get terrible reception. To hold our phone up till we get a response and then read it. Here we go, found a different one. So S sender, WL/G ground, perfect. All right. The black wire coming from our wheelhouse loom is a ground. So I'm going to share this ground for the oil pressure sender and the coolant temperature sender. Sitting here, I've actually come up with a definitive test for figuring out if the size of the next boat is right. And I think it's sitting in the bilge like this and being able to drink the last bit of a beer without hitting your head. Can't do that here. Failed. Alright, I've got some extra black wire. So I'm going to connect this up to the ground for the water temperature sender. We'll extend it down to here and then we'll join them all up. Alright, got a connector onto our ground extension, or a negative extension. It's not really a ground. Okay, so the ground from our water temperature sender and the ground from the wheelhouse, I'm going to combine them to a single ring terminal and put them on the ground for the oil pressure sender. As with all the others, I'm not putting this heat shrink down until we can get over to a wharf, and then I'll get power and I'm just going to use the heat gun to go nuts and do all of them. Does such a good job compared to a lighter. Alright, now this green needs to run up to the other terminal. Need to keep all this away from the exhaust manifold, of course, so I actually do have some heat-proof conduit. So let's give it about this much. The alternator is wired to the tacho correctly as far as I can see, but we weren't getting any reading on the tacho either, so I'll just confirm the wiring at the other end. Now, what have we got here? Red and yellow. I'm going to leave these at full length because they're not currently used. So it'll give us a little bit of future proofing. If we add, maybe gearbox temperature sender, something like that, there's more than enough length to reach there, which is great. So let's just pop that there for now and sort it out in a minute. Alright, let's go up in the wheelhouse and see if we've got any readings on either of these gauges. I think last time we looked at this, the light wasn't working on the oil pressure gauge properly. It was sort of dim. Turns out there's ignition 12 volt and permanent 12 volt. When I connected the second 12 volt, it seemed to work fine. But now, none of the gauges are working at all. But I've noticed I'm actually only getting 8 volts. I've got a voltage drop somewhere, so I'm just rechecking all the connections at the moment. Pretty tedious, but what else can you do? If I put the multimeter across the terminals of the switch, it shows a 5 volt drop across the switch. Looks like our water temperature is climbing. So, looks like one of the 3 gauges is actually working. We're actually sitting in gear at the moment. I've just got the engine in reverse pulling against the mooring line just so it's got a bit of load on it. I'm bringing the revs up a little bit too. I don't want to idle this engine to death. They don't like to idle too long, Detroits. As well as being better for the engine, it's going to help bed that cutlass bearing in as well every minute I've got it actually running in gear. Still really got to figure out why this is happening since I put the alternator on. So, 1 thing working, 3 things not working. You'll be pleased to know that I'm still in the process of cleaning up my electrical wiring. Starting to look alright now. A few things to fix up here still, but getting better. Well, thanks for watching. Good and bad I guess this week. Frustrating problems with the electrics, getting these gauges to work. I feel like they should be pretty straightforward, but I don't know, something's up with them definitely. Good news is the engine's running pretty sweetly. Obviously we need to put those new fuel filters in place, but I'm just going to do that as soon as those fittings arrive that have been taking forever. Now, it's probably worth mentioning just quickly that although people made some really good suggestions about how the buffer screw is there to stop the hunting in the engine, and it's true, it's what the buffer screw does, but I always try when you're diagnosing these types of problems to not rush in and change settings like that. When I was doing my coxswain's course, there was a marine engineering component, and something that always stuck with me was the teacher there said the very first step when trying to fix a problem with an engine is to put your hands in your pockets. And I think it's a really good advice, don't rush into changing anything. A classic example of this is when I see people having problems with their outboards. They'll dive in and they'll change mixture screws, idle settings, timing, all this kind of stuff. And you go, oh, why? What's changed? What's up with it? And you go, oh, I don't know, nothing's changed, it's not running well. And it turns out it's, water in the fuel or a clogged fuel filter or something like that. So I try to always
check the things that can change, the things that can go wrong before you start changing a setting that was perfect. You know, even if you can get it to run okay by changing that setting, chances are you're just compensating for a problem. You've got a blocked fuel filter, so you're, you know, opening an idle valve to make it richer, but really you're not solving the problem. So just something to be aware of when you're diagnosing these types of problems. Now, getting back to the electrics, I know my problem's not really related to the voltage drop across the switch, because if I take the switch out and I put the jumper in to just short it, the voltage across the gauges goes up to 13 volts, but they still don't work. So obviously that's not the problem. I believe the problem with this voltage drop has to do with there being a relatively high resistance in these switches, perhaps because they've got LEDs, they're lit switches. But the only way you would get a big voltage drop is if that was a significant proportion of the overall circuit, you know, resistance. And I can't see how these devices, you know, the gauges can have a really low resistance, because then you'd have a really high current draw. So, you know, I'm not an expert on this sort of stuff. I probably understand just enough to be dangerous, you know, but I'm thinking maybe the problem lies elsewhere. So, tacho, don't know. It's pretty straightforward, you know. I think what I need to do is maybe get some sort of AC oscilloscopy type, you know, tester and have a look what's coming out of the W port. I mean, maybe we've got a fault with the alternator that's causing my current draw when it's running. That's also meaning the tacho's not working. Maybe I just wired it up wrong. I don't know. You know, this in the car world, you tend to just have a faulty one. You test it, not working. Oh well, unplug it, out it goes. Plug a new one in, good as gold. So maybe I have done something wrong with the wiring. I'm sure people will tell me. Obviously, our coolant temperature gauge was working in the end. I just didn't run it long enough previously to see the needle come up. So that's great. I also have the infrared thermometer, so we can keep an eye on some temperatures around the place as well using that. The oil pressure gauge is really my next focus. I can live without the tacho, obviously, but I really do want the oil pressure gauge to be working. Now, I know oil is being pumped around the engine because the remote oil filter is getting warm, so I know that oil is passing through it, which is great. It's a recently rebuilt engine. To have oil pressure, you have to have a volume of oil being moved around and a certain restriction of that oil, i.e. tight tolerances, to give you oil pressure. So I think knowing it's being pumped and being a recently rebuilt engine, I think we're pretty safe. But what I think I will do is try and get a mechanical oil pressure gauge to put straight into the block in one of the other pickup points. That way we, you know, we'll have a reliable mechanical one all the time, even when the wheelhouse gauge is working, and it's one we can see while you're in the engine bay as well. So a few things to try and sort out, and fingers crossed, next video you see on the weekend will be our first cruise finally. All right, well, take care, stay safe, and we'll catch you then. See ya.
A slightly long D-Squad update this week. For ages I've been meaning to put a camera in their hutch before they go to bed, just to see what their sort of routine is. I think Dottie noticed the camera, particularly the fact that when it's recording it's got a flashing light on it, so I think that's kind of affected their behaviour slightly, but it was interesting nonetheless to watch. She definitely seems super suspicious and seems to be looking towards where I did mount the camera.